Good day, grade 12s. Welcome to Technical Mathematics. Today we are going to be discussing integration. Remember, this topic is the first topic that we were introduced in grade 12. So we also have to revise it thoroughly before we go and write our final exam. And then before we can start with this lesson, we should also go to examination guideline and just look into that document. What do they say about the integration, or things that needs to be known before you write the final exam? So it's very, very important. And we should also go to the previous question paper and check how did they ask this question that falls under integration. It's very, very important. Now remember, we normally take different calculus together with integration, but today I decided only to discuss the integration part only, so that we understand deeply into this topic. All right, so it's very, very important to use previous question paper, because remember, this technical mathematics is new to us. I think the first exam for grade 12, it was on 2018, right? So now if we can just go to 2018 and get the exemplars as well as the previous question paper and just go through that, all those question paper, and look how do they ask question under integration. It's very, very important. All right. Now let's see what are we going to be discussing under the integration for today's lesson. All right, under content, we have only integration, as I was saying that we are going to only discuss integration, because normally other videos I will do the differential calculus together with the integration. All right, and then when it comes to integration, I'm not getting into depth. All right, so now today I'm going to try my level best to explain everything that you need to know under integration. So it's very important as well. So let us make sure that we collect all the marks, because there's nothing difficult under this integration. You just have to understand the procedures, you just understand the rules that we have to apply when answering question under integration. All right, and then when you go and answer questions such as determining the area under the curve, there is only one procedure. So you just also have to understand that procedure on where do we start and how do we determine that area. So it's very important. So I think if we can just revise with previous question papers and then get some example also from the textbook, then I think you are going to get everything right under integration. All right. Now let's start. Let's see what are we going to be touching under integration. After completing the integration, you must be able to, number one, apply the standard forms of integration as converse of differentiation. Remember, when we compare the integral together with differentiation, we are saying integration is antiderivative. All right, it's antiderivative. It's like we are going back. It's like when you derive, and then when you go back is when you apply the integration. All right, remember, when you apply the differentiation, for instance, if we have let me try to write with my pen here. If, for instance, if we have f of x is equals to x squared, and then they say determine the derivative of the following f of x, then when you determine the derivative of this is going to be f prime. Sorry, let me just fix this one. The thing is that my pen is not writing very well, but I think you will see what I'm trying to explain. F of x, f prime of x, if you start deriving, so the answer is going to be 2x, right? So how did we come to that answer of 2x? We drop this exponent 2 to this side, and then we minus that 2 with 1. then we're going to have 2x. So that is the derivative. Now, when we have this question, which is, what is this, 2x, then we have to use the integration. We're going to draw the integral sign, and you say 2x. We're going to say this dx, right? It's going to be like this. And then if you apply the integration rules, is going to be what? It's going to be 2x to the power of 2 divided by 2 plus what? Plus c, which is the answer is x squared, because this 2 is going to cancel this one. So the answer is going to be x squared plus c. Now you can see it gives us the original before we start using what? Derivative. Remember, before derivative it was x squared, and then after derivative it was 2x. And then if you take that 2x and then we apply the integration rules, then it's going to take us back to x squared. So hence we are saying you must be able to apply the integration as a converse of differentiation, meaning it's antiderivative. All right. And then we then go to this one that says apply the rules for integration for the function. This one that says kx to the power of n, where n is the element of all real numbers, and then n should not be equal to -1. Then this one, k divided by x, and then k a to the power of n x. All right. And then apply the integration to determine the magnitude. The magnitude we're referring to the size of an area, or the magnitude of the area included by a curve and the x-axis, or a curve, the x-axis, and the ordinates, such as x equals to a and x equals to b, where a and b element of integers. So these are the things that we are going to be discussing for today's lesson. So that is for integration, or everything that needs to be revised. All right, let's start and determine the integral. Determine the integral of integral 3 dt, and the other one is integral of that. Now let's see the solution. So we are going to start solving the first one. You can see we are doing the integral of 3 dt, meaning we are going to integrate with respect to t. It's not x, because we normally use x, and then you'll find that learners, when they answering questions, they forget that you should check that you integrate with respect to what, because most of the time we use x, you use x. So now, if now it is in terms of t, a learner will write x instead of t, and then we are not going to get it right, because remember, we integrate with respect to t, not x. So you always, every time when you come to integrals or integration questions, please check what are you integrating with respect to what. This one, in this case, is dt, meaning with respect to t. Then what is going to be the answer? I think we have started answering the second one. All right, this one I think is going to come later. Let's see the second one on how do we go about it. Now, before you can integrate this one, the second one, we need to first get rid of this division sign. We first need to get rid of that. Now, how do we do that? First, we're going to say 2x to the power a divided by x cubed. That's number one. That's step number one. Number two, you say x to the power 5 divided by x to the power 3. That is the second one. And then we say 13x squared divided by x cubed. That is the third one. The third step, you then simplify it. And we know that if we have the same base as x, then we divide, we minus the exponent. Hence we say 8 minus 3 is going to give us 5. So answer is going to be 2x to the power 5. And then also here 5 minus 3 is 2, then x to the power of 2. And then a here is going to give us negative 1. All right. Now this one is also very, very important, but I'm going to explain after we have determined the answer. If the exponent of that x is negative 1, then we'll see what's going to happen. What is the answer? Now let's start with this one. Let's say 2x to the power 6 divided by 6. How did we obtain 6? Remember, the integration rule says we add with plus 1 here, and then we also divide with what do you have as the as exponent. And then as exponent, we are having 5 plus 1, which is 6. Hence, you see 6 here. So you're going to divide, simplify it. You can just say 2 into 2, 1 into 6 is 3. So the answer is going to be x to the power 6 over 3. And then here we have x power 2. Then if we add plus 1 here, it's going to be 3 divided by 3. That is the correct one. And then now, if the exponent is negative 1, then you just introduce what? Ln. So how do you introduce ln? You're going to say 13 ln x plus c. And then please don't forget to write this c, because sometimes they do reward a mark for just writing c. So under integration, please let us include c, all right? But not when we are going to be dealing with definite integral. Definite integral, we don't include c, but that one I'm going to explain it later when we get there. But now, for this one, please let us make sure that we always include c. It's very, very important. Now let's deal with that one. This question, which integral 3 dt. Then what is the answer for this one? The answer is going to be 3t plus c, not x. 3t plus c. Remember, you take it back. This is the anti-derivative. It's like you have derived it and then you have to take it back, right? So if it was now is 3, now before it was 3t. So hence we have been 3t plus c, all right? Now let's go to the next question. Determine the following integral. The first one, the second one, and then we have only 2. Now look at the first one. The integral sign into negative 6 over x. Now, I just want to explain this one. If the denominator is x, right, then you should know that you are going to be introducing ln, not x squared. I'm saying if the denominator is x with the exponent 1, not 2, not 3, not 4, but exponent 1. Like what we are having, you can see denominator we are having x and exponent is 1. Then that's where we're going to be introducing ln. Now let's see on how do we introduce this ln. This is the answer. The answer for this one is going to be negative 6 ln x plus c. All right, ln x, I mean negative 6 ln x plus c. Don't forget to write c. They sometimes do what? They will just give you the integral sign and then give you 6 over t dt. What is going to be the answer? The answer is going to be what? It's going to be 6 ln t plus c. All right, plus c. 6 ln t plus c. So please, every time when you, I know this integration is simple. So, but what learners do, they just rush to answer question without checking what are they integrating with respect to what. You see, so because we normally work with x, so they will just assume that, oh, it's x, then they will just write. not knowing that it's no longer x, but it's maybe it's other a variable. All right, now, but this one is x is fine, hence we are having -6 ln x c. Now the second one, let's see. Now if we are having a bracket and a square, now we cannot be able to apply the rules of integration, because if it's like this, there's no way. How are we going to do it? We can't. We first have to get rid of that exponent 2. Now, how do you get rid of that? Because it's say x minus 1 all squared, then it simply means we are going to have these two brackets, because 2 means we're having the same bracket, which is x minus 1, x minus 1. And then from there, you apply a FOIL, you just multiply those two binomials, and then this is going to be the answer after applying them. It's going to be x squared minus 2x plus 1 dx. Now, if it is in this form, it's fine. You can now start integrating, all right? And then if it is having more than one terms, it's fine. You can also write it in this manner. You can say the integration, the x squared dx, that's step number 1, minus integration 2x dx plus integration of 1 dx. So when you are doing integral, or you integrate by parts, it's when you're doing by parts. You can also do it like this, or you can just continue and then apply the rules in every term, and then you get the answer. That's it. So it will depend. Now let's now start to apply the rules of integration, and then you can see this one is going to be what? X to the power 3 over 3. So meaning you always add your exponent with 1, and then the answer that you're going to get as the exponent, you're going to divide with it. That's why we are having exponent 3 divided by 3. Exponent 2 divided by 2. And this 2 can cancel. This 1 is fine. And then now 1 is going to be x plus c. Don't forget to write that c. Evaluate the following integration. All right, we're now having the 3 questions. The first one, but remember we previously had similar question like this one, where the denominator is x, and I did explain if the denominator is x, then we just introduce ln. Now let's see on how to answer this first question. The answer is going to be 3 ln x plus c. That is the first one. You get full marks. The second question, we are now having what? Integral x squared plus pi dx. So don't be scared of this pi and say, so what are we going to do with this pi? Remember, pi is a number. Pi, is it a number? It's 3,14 something. All right. So we are going to take it as a constant number. And then you know that under integration, if we have a constant number, what are we going to answer that question? Now let's see on how to answer this one. So the answer is going to be x to the power of 3 divided by 3 pi x. Pi x, you can see. So because, for instance, you remember we had a similar question like this. We had 1 and it was x. We also had, I think it was 5, and then the answer, no, it was 3, and the answer was 3t. All right, because that 3 is a constant number, then we have to take it back. Then we just put a variable in front of it or after it. Now this one is pi x plus c. And then the third question, now we solve with respect to t, right? Then the answer is going to be t to the power 3 over 3 plus t squared over 2 plus x dt plus c. Because we have put x there, don't panic, don't think it's a mistake. You just have to check here, what are we integrating with respect to what? This is t, meaning that x, we are going to take it as the constant number. Hence our answer is xt plus c. All right. All right, find the following integrals. Let's see the first one. This is what we're having. Now we integrate with respect to x. Now the answer is going to be what? We remember we add 1 as exponent, you divide with it. Then the answer is going to be 3x power 4 over 4 plus c. That is the correct one. And the second one, we have this one now. Let's see what is the answer. The answer is going to be x to the power 4 divided by 4 minus 2x to the power 3 over 3. That is the second one. And then plus x squared plus over 2 minus 5x plus c. Then you will find this question, it might cost a lot of marks. You can get how many? 1, 2, 3, 4. So this is how they mark during the marking center. During the marking, this is how they should mark it. They mark according to the each question, each answer. They mark each answer, and then they sometimes mark the value of c. So in this question, you might get 4 if not 5. All right. And then the third question, integral 7x, then the answer is going to be 7 ln x plus c. All right, now the first one, we're having 100 divided by x plus x squared dx. Now this one of where we are having denominator as x, remember we just introduced ln, so it's going to be 100 ln x. And then now this one is going to be x to the power 3 of 3 plus c. That is the correct one. All right. The second question, which is this one, then what is the answer? Negative x squared over 2 plus 5. Look at this one. 5 over 6 ln x plus c. All right. Then this one is going to give us x, right? And then this is plus c. And then the last question, negative 1 over x plus 6. So it's going to give us negative 1 ln x. So there's no need to write 1 there. Just write negative ln x plus 6x plus c. That is the correct one. All right, we are done with the first one where we are applying the rule of integration. And then now we are going to apply the integration to determine the magnitude of an area. We are now going to be calculating the area under the curve. And then when we are going to apply the definite integral, this one is a definite integral to calculate the area under the curve. And then definite integral defined by this. So now we can see that it has the lower limit, which is a, and then upper limit, which is b. All right. Now this one, every time when we have to answer it, we are no longer going to include that c. We are not going to add c for the definite integrals. All right. Now let's see on how do we deal with the definite integral. A sketch below to present the bounded area of the function defined by f of x. Sorry, let me just remove that line. F of x equals to x squared. Determine the area of the shaded part of the graph of x. You can see the shaded part is this one. All right. So in the shaded part, we are only interested on the lower limit and the upper limit. What is the lower limit and what is the upper limit? That's where we're going to start calculating our area. And then first we write this one, and the lower limit is 2 and the upper limit is 3, x squared dx. Then second step, you apply the rules of integration. Then this one is going to give us x to the power 3 divided by 3. And then you just put your upper limit and the lower limit on the right hand side. All right. After that, the third step, you start substituting with the upper limit. Yes, you can see where you see x, you just put 3. minus the lower limit, which is 2. Then you just press your calculator, and that is going to give us 6,333 units squared. So that is the area of this shaded part there. All right. And the second one, determine the area of the shaded part of the graph of f of x equals to 2x squared plus 4x. This is the graph that we are having. All right. Now we can see that the area that we are in need of is below the x-axis. Now, if you are in need of this area, which is below the x-axis, then you're just going to put a negative before the integral sign. All right, let's see on how do we answer that question. This is how you should answer it. You first start with negative, the integral sign. You then put the lower limit and the upper limit. The lower limit is -2 and the upper limit is 0. All right, this point and this point. So when you every time when you are dealing with area that is below the x-axis, then you have to calculate that area. Remember, you start with negative and the integral sign. Then from there you just negative, and then you apply the rules of the integration, and then from this going to give us 2x to the power 3 over 3, 4x squared over 2, and then you just put your upper and the lower limit this side. Then from there you put square bracket, the big bracket, and the negative, then you put everything. Then you start substituting with the upper limit. You can see this is 0 is 0, and then from there you put -2, -2. Then you take your calculator and put everything in your calculator. Then it's going to give us our answer as 2,67 units squared. You must always write units squared to show that we are calculating the area, right? Units squared. The graph of f defined by the f of x equals to negative x cubed plus 6x squared is drawn below. You can see the graph. This is the cubic equation. Not equation, but the graph, cubic graph is this one. Determine the area of the shaded region of the graph of f bounded by the graph and the x-axis between x equals to 1 and x equals to 4. Then you write the integral sign, having the lower limit which equals to 1 and the upper limit which is equals to 4. Then you put the equation there. Then the second step, you apply the rules of integration. This is the answer, -x power 4 over 4 plus 6x to the power 3 over 3. Then you put your upper limit and the lower limit there. You start substituting with the upper limit, which is 4 minus, and the lower limit, which is 1 and 1. Then from there, you take your calculator and put everything on your calculator, and the area of that particular region is 62,25 units squared. All right. The sketch below represents the bounded area of the curve of the function defined by f of x equals to x squared plus 3. Determine the shaded area bounded by the curve and the x-axis between the point where x equals to 3, x equals to 2, and x equals to 1. First, write the integration and the lower limit, which is -2, and then upper limit, which is 1. Then the second step, what you do, you are going to substituting. All right, it's correct. X squared, x to the power 3 over 3. That's correct one. And then this one is x 3x. That's correct. And the upper limit and the lower limit. The third step, you start substituting there. upper limit 1 and 1, and then minus, you then substitute with what? With lower limit, which is -2. Then you press your calculator, the answer is going to give us 12 units squared. Right. So this is how you should answer, or how you should calculate the area under the curve. It's quite simple, straightforward. You just need to understand the procedure, right? Now we are having this question now that says the graph defined by f of x equals to x cubed minus 3x squared minus 3, minus x plus 3 is drawn below. The x-intercept of the graph is x equals to 3, x equals to 1, or equals to 3. You can see the cubic function, and even this, the cubic function, you can see the cubic equation. And now let's see, determine the area of the stripped region of the graph of f bounded by the graph and the x-axis, where x equals to -1 and x equals to, meaning from this point until the here we need to calculate the area. So we first going to start calculating the area of the shaded part above the x-axis from -1 to 1, right? Then you write the integral, which is the integral sign with -1 plus 1. -1 is going to be the lower limit, and the 1 is going to be upper limit. And then from there you start integrating. There's going to be x to the power 4 over 2, x to the power 4 over 4 minus 3, x to the power 3 over 3. Then this 3 can also be cancelled. This one is fine. And then we have -x squared over 2 plus 3x. Then you start substituting with the upper limit, and then minus your lower limit, and the area that is above the x-axis, it gives us 4 units. We are now have to calculate this area below the x-axis. Now remember what I said about calculating the area below x-axis. You always start with negative, then the integral sign, then you put your lower and upper limit. Let's see. It's going to be negative. The lower limit is 1 and the upper limit is 3. Then you continue with this negative, then you apply the rules of integration. So this is the answer that we got here. And then now you just have to put your upper limit and the lower limit. You then substitute with the you substitute your upper limit first. You then have to substitute with lower limit after. Then from there you say the area is 4 units squared. Now if we want the total area of both shaded region or the trip region, then it's going to give us how much? 8 units. You're just going to add the 2. That's going to give us 8 units squared. All right. All right. Thank you very much for being part of this lesson. I hope everything that we have touched is going to have an impact on you while you are busy preparing for this coming final exam. So like I said, that please let us make sure that we use the previous question paper. It's very, very important. It's very, very important to use that, and we should also have the examination guideline. And then let me just leave you with these words before that says never give up, and today is harder, tomorrow will be worse, but the day after tomorrow will be sunshine. All right, so never give up. Even if you did not do well during your trial examination, just look into what went wrong and then check everything, and then after you try to rectify what you did, and then from there you use the previous question paper. Like I've said, use previous question paper and check on how these people ask these questions. All right. All right. Thank you very much. Have a nice evening. See you next lesson. Bye.